different chemical formulations. For the most part, do the same thing. The difference is the 226, when you put it on, you just wipe it on. The activator, you have to wipe on, wipe off. What you can do is you can put it on too thick, and it actually acts as a weak layer. The key thing first on almost all surfaces, scuff it a little bit. And just simple Scotch-Brite is all you need. You just need to knock off a little bit of the surface. And I actually scuffed too much there. You just need to just give it a quick wipe. Then moisten the cloth. See how much junk that picked up. You want to change your wiping surface fairly often. Again, wipe in one direction. Doing this, all you do is just wiping dirt around. So you just want to go in one direction, lift as you go, change the surface, usually every couple feet, 2-3 feet. And the other key is, this stuff is really moisture sensitive, and you can't tell if it's become ineffective. You need to put that inner cap back on. You wait 10 minutes, there's a chemical reaction going on with the surface. And then we're going to get into the primer. The different primers we have, we've got 215, which is for some plastics, fiberglass, and wood. Critical for teak, and also for hull seams. You definitely want to do that when you're doing hull seams. 209N is, again, critical for polycarbonate bonding, and for if you're bonding to a paint surface like a powder coat, works real well as well. And then 206 GMP is black primer, metals, fiberglass. It does work on some other things we don't market it for, but like wood, it does a pretty good job on it, but it's real black. If it gets where you don't want it, it's there forever. The key with this one, the black one, you do need to shake them up pretty good because there is some separation going on in there. Basically the trick is just spread that on, go with the thinnest coat possible. What you do with polycarbonate obviously is tape off your edges first. You do need to scuff it a little bit. If it's got a Margard finish on it or an anti-scuff finish, you need to grind it about a 1/16 of an inch down below the finish. So you scuff it, and then we're going to take Sika Cleaner 226. The 226 cleaner, what the cleaner does is it basically pre-cleans the surface and also prepares it to accept the primer. What you do is you moisten it with the cloth. You want to be careful not to get it on the glass surface because it does leave a slight film behind at certain angles you can see. Just wipe that on and wait 10 minutes. The next step we're going to do is 209N. This one is a black primer mainly for polycarbonate. We do also use it a little bit on powder coated metals. With the black ones, you do need to shake them up. They do separate out a little bit. Now you do want to pull off the inner liner. With any of the cleaners or primers, you want to make sure to seal them up right away when you start using them. And again, this is just spread it out. This one's a 30-minute wait, and then we would gun on the Sika Flex and press it together. Marine side, Sika Flex 292 is going to be the key adhesive. Good for bonding cabin walls on, stringers, deck wall bonding, that kind of thing. Just as a side, one thing I want to talk about is guns. With a cheaper gun like this one has a mechanical ratio of, for every pound you put on here, you put about 3 to 4 pounds on here. This one's an 18 to 1. When you stop gunning and release the pressure on the gun, this is called a cutoff string. Most urethanes, most of our products have a fairly short cutoff string, anywhere from virtually nothing to an inch or two. I want to get into a little bit on technique. The trick is to get just the right amount on, not trap any air in there, not put too much on, which is what most people tend to do, and to put it on in the right way. What most people tend to do is they gun the stuff on, and they put too much on, and they pull behind, and they tend to skip a little bit like that. The trick is to push it ahead of you, just a slight wave. See how I got it going just ahead of the gun? what you're doing is you're pushing any air out. So you have no chance, you're holding contact with the surface, pushing it out, and you've got no chance of trapping air in there. And the other thing is, you kind of know when you got enough when you tool it, and you don't have a ton of it all over your fingers. That's really, it's kind of a, let me do this one. I'll put too much on like people tend to do. And I tool it, I got a ton left. And you can see it's just not a nice looking bead, quite a bit different. If you take a look at a regular round bead, and you put your other surface on top, no matter what you press down, what happens is the bead may spread out, but your contact area is still really minimal. Very little contact area. Where if you're doing the bead, put the other surface on top, what ends up happening is you get a controlled spread as it pushes down, and it also forces out any air pockets in there. What can happen on these is as you push down, you actually create an air pocket in there, and which is nothing but a leak and a weakness point. You want to hold it at a 90-degree angle, and just gun out like you normally would. The adhesives generally get into what's called high viscosity. They're very thick. They just don't go anywhere. I mean, you can bang that thing and it's hardly going anywhere. It's not really moving at all. But what the V does, you can watch that. See how it just spreads it out nice and wide? Now with viscosity again, you get pretty good green strength. It really just doesn't go anywhere. Even like that, I mean, hold the weight of the steel's probably a quarter of a pound.